So we're going to be using this to do some other stuff later on, but we need this as a starting point. We're going to be using this later on to help us with converting from a decimal number to a fraction number. When we're doing that, we're going to use the decimal places over here. We're going to need to know what those values are. But let's start with the ones to the left of the decimal point. To the left of the decimal point, I've got the ones on there already. And let's just work our way left from there. So left of the ones place, what's this place going to be?
10.
That's going to be the tens place. And then left of the tens place is the hundreds. And then the next one is thousands. Now I'm gonna add a word in there. I'm gonna call it the 1,000s place, and we'll talk about why I did that later. But that is the thousands place or the 1,000s place. Then the next one is 10,000s. Then 100,000s, and then millions. And again, I'm gonna put a 1 in front of it. So that's the 1 millions place. It's okay if you didn't do that, but I'll talk about why I did that in a second. Then we had the 10 millions in there already, and then the last one there is 100 millions. Now, notice at the top I've got these curly brackets up here over the groups. So every 3 decimal places starting at the decimal point, we put a comma in there when we write a number. So if we're writing a big number that's in the thousands or millions or even bigger, we're going to put commas in there. Each of those groups has a name. This one right here is pretty simple. It's pretty straightforward. It actually has the same name as this place right here, the ones place, and that's just the ones group. All right, what is this group called? What do all 3 of these have in common? They're all thousands, right? So in this group we have 1,000s, 10,000s, and 100,000s. So all of the place values in the thousands group are exactly the same as the place values in the ones group, except it has thousands on the end. So that's the thousands group. The next group is the millions group. And it just keeps going. There's another group of 3, and then another group of 3, and then another group of 3. Does anybody know what the next group bigger than millions is? Billions. Yeah. Anybody know what's bigger than that? Trillions. Anybody after that?
Quadrillion.
So we have billion, starts with B-I. Bi means 2. Trillion is means 3. So what'd you say, Cammie? Quadrillion, yep. So quadrillion would be the next one, and then quintillion, and it just keeps going.
What's a zillion? Is that a made-up word?
That's a made-up word, yeah. There's no such thing as a zillion. It sounds cool, though, doesn't it? Sounds like a lot. Okay, so now the important ones for today, those are the ones after the decimal place. All right, all of the ones that are after the decimal place are going to end in the same 3 letters. What are they going to end in? THS, right? And what that means is it's actually going to be a fraction. So any number in the ones place has a value of 1. Any number in the tens place has a value of 10. So like if I put a 5 in the tens place, that would be like having 5 $10 bills. Okay, so it actually wouldn't have a value of 5. If I put a 5 there, it would have a value of, let me put this here. What would that actually have a value of in that place? That's the same as 5 $10 bills, so it would be $50, right? If I put the 5 in the millions place, it doesn't mean 50 anymore, but it means what? 5 million, right? Okay, so over here to the right of the decimal, when I put numbers in, it's going to mean a fraction of something. All right, so the first one here is going to be what? What place value is the first one after the decimal? Anybody know? That's the tenths place. All right, so what this means, and if we write that as a fraction, 1/10, so if I put a number in there, like 1, 1/10, we would write just 1 over 10. So it's a fraction, something over 10. And that's going to be the important part with our conversions today. In the next place to the right of that is going to be hundredths. And the next place after that is thousandths. And the next one after that is 10,000ths. And this is going to keep going in the same order that these did. Okay, so going to the right, we had tenths, which is 1 over 10. We had hundredths, which is 1 over 100. 1,000ths. Then we're going to have, after that, 10,000ths, and then 100,000ths, and millionths, and it just keeps going to the right. And it has the same groups going to the right as it does to the left. It's just fractions. Okay? One quick question. Why is there not a oneths place? Let me write that word down. It's kind of a weird word. Why is there not a oneths place? What would that mean? So a tenth is something over 10, and a hundredth is something over 100, and so on. So what would a oneth be if that was such a thing? It would be something over 1, right? 1 over 1. Well, what is 1 over 1? 1. So a oneths place would be the same as the ones place. So there's no such thing as a oneths place. All right, so we skip over that. We skip over the oneths to the right of the decimal, and we go straight to the tenths place. Okay, so we're going to need this now to convert a decimal number into a fraction. All right, that's going to be a really useful thing. We did talk earlier, I'll add them on there, we talked about the billions place, or the billions group, so we would have 1 billions, 10 billions, 100 billions, trillions, quadrillions, quintillions, sextillions, septillions. Anybody know what 8 is? Octillions, yep. How about 9? Anybody know German?
No.
I don't know, I guess it's not the same in German. Nonillion, it's just N-O-N, and keeps going on and on. So, for example, this 5 right here, I'm going to stick with the 5 because I was using that earlier. What is the value of this 5 right here? It's not like $5, but it would be what? What does that 5 represent? What place value is it in?
50,000.
Well, it's in the 10,000s place, right? So it has a value of 50,000. All right, this 6 right here, even though it's bigger than the 5, has a much smaller value because it's in the hundredths place. So that would actually be the same as like 6 cents, because a cent is 100th of a dollar. So depending on where we put the number, it has a very different value. All right, so we're going to use this now to help us convert from a decimal into a fraction. So this is what we're going to write down at the bottom. This is our goal for today, is to be able to take a number that's a decimal, has a decimal point in it, and change it into a fraction. The first thing we need to do is we need to identify the place value of the last digit in the decimal. So we're going to determine the place value of the last digit. So out of all the digits in the number, we're going to look at the one farthest to the right, and we're going to determine the value of that one. Since we're talking about changing a decimal into a fraction, the decimals are going to be the numbers to the right of the decimal point. So when we're doing this first step here, we're going to be looking at like the tenths place, or the hundredths place, or the thousandths. So those are the ones where we're going to be getting fractions. All right, once we figure out what the place value is of that last digit, the one farthest to the right, then what we're going to do is we're going to write a fraction. Okay, so we're just going to make a fraction bar, and we're going to use the decimal without the decimal point. So the number that we're starting with, we take the decimal point out, and that goes on top in the numerator, and then the place value is the denominator. So for example, if the last digit is in the hundredths place, we're going to put 100 in the denominator. At this point, we're going to have a fraction, but it might not be our final answer. What do we always want to make sure we do when we have a fraction as an answer? Simplify it. So our last step anytime we get a fraction is to simplify or reduce. I will say that reducing here is a little bit easier than reducing fractions in general, because there's only a few things that we can reduce by. When we're reducing here, think about what's going to be in the denominator. If the number's in the tenths place, then we're going to have a 10 in the denominator. If it's in the hundredths, then we're going to have 100. Or if it's in the thousandths, then we're going to have 1,000. So what is the number in the denominator always going to end with? It's always going to end with a 0, right? Sometimes 1 0, sometimes more, but it's always going to end in a 0. So a number that ends in a 0 can be divided by 10, but it can also be divided by 2 other numbers. What other 2 numbers could a number that ends in 0 be divided by? 5 and, well, we already said 10 though. So it's divisible by 5. So for example, 10 divided by 5 is 2. 100 divided by 5 is 20. 1,000 divided by 5 is 200. So we could divide them by 5. What else? Taylor? No, not 3. 2, right? Aren't these all even numbers? Since they're even numbers, we know they're divisible by 2. So when we're reducing, all we really need to do is check those 2 numbers. And we'll talk more about that later, but it makes things a little bit simpler for us. All right, so here's example 1. This is our first one at the top on the back. We want to convert these numbers to a fraction, and we're going to have to do this without a calculator that has a fraction button. All right, you will have to You'll have to show all your work for this, and you're going to have to show each of those steps that we wrote down. And so the only calculators you're going to be able to use are the ones that we gave you. All right, so the first step is what? I know it's on the other side of your paper, but what's the first thing we need to do? We need to figure out the place value of the last digit. Here's the last digit. It's pretty easy. Farthest to the right is that 9. What place value is that 9 in? It's the first one after the decimal is the 10th place. All right, so I'm going to write that down here. You don't have to do this. You don't have to write it down when we're doing this, but I'm going to write that there. All right, so we have that 9 in the 10th place. So the next step then says we're going to write a fraction. So I'm going to make my fraction bar. The numerator is going to be the number without the decimal. So I'm going to take this 0.9 and take the decimal off. So I write 0.9. Should I do that? No. What don't I need there? Yeah, we don't need that leading 0. We don't need that 0 in front. So we take the decimal off, which means we can also take the 0 off and we just get 9. All right, on the bottom, we're going to put the place value of, well, that 9. What is the place value? The 10th place, so it's going to be 9 over 10. All right, that's step 2. Step 3 says reduce. Can I reduce this? Is there anything that goes into 9 that also goes into 10? Nope. So we're done. Don't forget to box your answers. All right, example 2. Again, the first thing we're going to do is we're going to identify the place value of the last digit. This time it's going to be the 7, the one farthest to the right. What is this place value right here? That's the 100th place. Notice the THS at the end of that there. So when we make our fraction on top, we're just going to write the number without the decimal, and again we can drop off that 0. So what do we get on top? 17. And then on the bottom, we're going to have 100. Now, is there anything that goes into 17 that also goes into 100? No. So that is it. It's just 17 over 100. All right, and actually, I don't know if you guys knew this, but the way we would actually read this number as a decimal, since the 7 is in the 100th place, we would read it as 17 hundredths. It's the same way we would read the fraction. So if we say 17 hundredths, that represents this decimal and also represents this fraction. Kind of cool, right? Sure, Mr. Betts. Okay, so I already talked about this, but since the numbers we're going to get in the denominator are always going to end in a 0, we know they can be divided by 10, but we're actually probably never going to reduce by 10. And I'll talk about why we would not reduce by 10 later. But 10 is divisible by what two numbers? 2 and 5, right? So if the fraction can be reduced, you're going to be able to reduce by either 2 or 5. Now, you might be able to reduce by 2 more than one time, or reduce by 5 more than one time, or maybe even both. Although if we could reduce by both 2 and 5, then that means we could have reduced by 10 to begin with. So let's talk about this real quick before we move on. How can I tell if I can reduce by 5? How do I know if a number is divisible by, I said 5, I meant 2. How do I know if a number is divisible by 2? Carl? It's an even number, exactly. So if the number is even, then it's divisible by 2. I would write that underneath there just as a note. If it's an even number, it's going to end in what? Ends in, what are the possible ways an even number could end? 0, 2, 4, 6, 8. So if the number ends in one of those 5 numbers, then it's even, it's divisible by 2. All right, since the bottom number is going to end in a 0, I know that's divisible by 2. So if we check the top number and it's also even, then we will reduce by 2. All right, how about 5? I know the bottom number is going to end in a 0, which means that it's divisible by 5. How else can I tell if a number is divisible by 5? Divisible by 5. It ends in what? Ends in 0 or 5. Any number that ends in 5 is divisible by 5. All right, so again, we know the bottom number is going to end in a 0, so I know the bottom is divisible by 5. what I'm going to do is check the top number and see if that's also divisible by 5. All right, so let's look at some examples where we're actually going to have to reduce. This one looks fun, doesn't it? So the first step is to figure out what is the place value of the farthest digit to the right. So let's just start at the decimal. The first one after the 6 is in what place? Tenths, and then hundredths, thousandths, and then 10,000ths. I'm going to just write it like this, 10,000ths place. So when I write it as a fraction, I'm going to write the number without the decimal. And that means also I can take that 0 off in front. 6128 goes on top. And on the bottom, I'm going to get what? 10,000, right? Because it's in the 10,000ths place. Can I reduce by 5? No, because the 8 is not divisible by 5. All right, so all we have to do is look at the last digit here. Can I reduce by 2? Yes. All right, so we're going to reduce by 2. And we can go ahead and use a calculator for this part. Go ahead and punch into your calculator 6,128 divided by 2. And you're going to get what?
3,064.
Okay, and then on the bottom, we're going to divide 10,000 by 2 and get 5,000. Half of 10,000 is 5,000, right? Okay, so we reduced by 2. Are we done? No. So I will tell you this. We're not going to be able to reduce by something like 3 or 6 or 7 or 9. So again, if we can reduce, it's going to be by 2 or 5. So let's check those again. The first one wasn't divisible by 5, so it's not going to be divisible by 5 ever. So let's check 2 again. Is it divisible by 2? Yeah, let's divide by 2 again then. So we reduce by 2, top and bottom. And this time we get, what do we get on top? 1532. And on the bottom? 2,500? Okay. Are we done? No. Remember, check to see if it's still divisible by 2 or 5. Again, it's not going to be divisible by 5 because it wasn't from the beginning, but it is divisible by 2. So let's do that again. Let's divide by 2. All right, so when I divide that by 2, I'm going to just put an equal sign underneath here. 1532 divided by 2 is? 766 over 1,000, or I'm sorry, 2,500 divided by 2 is? 1250, 1,250. Are we done?
No.
Nope, got to go again, right? So let's divide by 2 again. How many times do you think we're going to be able to do this? Forever?
Yeah.
I don't think it's going to be forever. There aren't many things that go on forever. 766 divided by 2 is? 383. Ooh, that's not divisible by 2, right? So I think we're probably going to be done. How about 1,250 divided by 2? 625. All right. Can I reduce by 2? No, they're both odd numbers now, right? So neither one of them can be divided by 2. What about 5? Can I reduce by 5? No. So we're done. You don't have to check anything else because there's nothing else that's going to go into this number on the bottom. All right, again, the only thing that can go into the numbers on the bottom would be 2 or 5 or multiples of 2 and 5. And that's not going to work here. Okay, how about this one? What's different about this one than all the other ones we've done so far? It's got a whole number part of it, right? So it's got a number on the other side of the decimal. It's actually not going to change anything that we do here. All right, so first thing we do is still looking at the rightmost number. What is the place value of that? That's the tenths place. So this is going to equal, we're going to take the number, but get rid of the decimal. So what do we get when we take the number with the decimal off? Take it away. We get 25, right? So it's going to be 25 over, what goes on the bottom? 10. And then I check to see if I can reduce. It's not divisible by 2 because 5 is odd, but it is divisible by 5, right? So we're going to reduce by 5. And on top, 25 divided by 5 is 5. And 10 divided by 5 is 2. Can I reduce that? No. It is, what kind of fraction is this? It's an improper fraction. That is okay. Actually, we like improper fractions better because it's easier to work with. If we change this to a mixed number, the mixed number would be 2.5. A mixed number has 3 parts to it, and an improper fraction only has 2 parts. So that makes improper fractions a lot easier to work with when we're doing other operations. So we're not going to use the mixed numbers. We're going to keep it as an improper fraction. That's just easier to work with. All right, example 5. This looks like it's going to be another fun one, doesn't it? All right, so what is the place value of this 5 right here? That is the 10,000th place, kind of like a couple of examples ago. So when I take the decimal off, what do I get? What's going to go on top? 625, exactly. So when I take the decimal off, I can also get rid of these zeros in front because they don't really change the value of this number. All right, so we get 625 on top, and what do we get on the bottom? 10,000. So we get 625 10,000, which is exactly how we would read this number. Now we need to do what? Yeah, we can reduce by 5. How can we tell really quickly that we can reduce by 5? Yeah, they end in 5 and 0. So we reduce by 5. 625 divided by 5 is 125. And 10,000 divided by 5 is 2,000. Okay, can we reduce that? Yep. Again, they end in 5 and 0, so we're going to reduce by 5 again. And 125 divided by 5 is 25. 2,000 divided by 5? 400. Okay. Are we done? No, we can reduce some more, right? What goes into both of those? 5. Remember, we only have to check 2 and 5, right? So we're going to reduce by 5. 25 divided by 5 is? And 400 divided by 5? 80. You can use your calculator for that. Just punch it in. 400 divided by 5 gives you 80. And are we done? No, we can still reduce by 5, right? So we'll do it, well, I know I can only do it one more time because when I reduce by 5 on top, I'm going to get what? 1. All right, that's never going to be able to reduce. So 5 divided by 5 is 1, and 80 divided by 5 is? 16. Real quick, before we go on to the next example, this is something we're going to talk about tomorrow, but I think you guys know how to do it. If I wanted to change a fraction like 1 over 16 into a decimal, what could I do? What does 1 over 16 mean? It means division, right? It means 1 divided by 16. So real quick, I want you to do something that's going to help you check your answer here. I want you to type into your calculator 1 divided by 16. Tell me what you get.
0.
Okay? So I said we're checking our answer. How does that confirm that we got the right answer? That's what we started with, right? So this right here, this 0.0625, that was the problem to begin with. So when I get my answer, what I can do is I can just type in 1 divided by 16 in my calculator and just check to make sure that I get what I started with. If I get something else, that means that I probably made a mistake while I was reducing somewhere along the way. So you'd want to go back and check your work then. All right, last one. I think this will be a pretty easy one to finish with here. Again, we have a whole number part of this, so we have something in front of the decimal, but it doesn't change anything we're going to do. We look at the place value of the 5, that last digit, and that's in what place? That's the 10th place. Since that's in the 10th place, what's the fraction going to look like? What do we get on top? 125. Again, it's just the number without the decimal. So we take that decimal out, and we have 125, so that's 125. On the bottom, what do we get? 10, because it's in the 10th place. And then can we reduce this?
Yes.
Yes. How do we know we can reduce it? It ends in a 5 and a 0, right? If it ends in a 5 or a 0, it's divisible by 5, so they're both divisible by 5. 125 divided by 5 is 25. 10 divided by 5 is 2. Can I reduce that?
No.
Can I reduce this one by 5 and this one by 2? No, it has to be the same thing, right? So this one's even, but this one's divisible by 5. It doesn't really help us out. So this is our final answer. And again, if we want to check our answer, we could punch into our calculator or what? 25 divided by 2. Does it work?
Yeah.
Yeah. You put 25 divided by 2 in your calculator, you get 12.5. So this is a good answer.